Hello. Let's first to make sure that the M1 proximity switch can work properly. First, we need to disassemble the housing. The M2.5 hex screwdriver is needed here. Then, let's take off the housing of the big arm, and there will be the 4 screws here. Remove 4 screws before removing the housing of the large arm. After removal of the large arm housing, here you can see a proximity switch. Next, we take down the housing of small arms. There will be 5 screws here. Both are removed with the 2 screwdrivers that can be used at the hexing of M2.5. Then, this side is a cross screw. Needs to be removed with a cross screw. Try breaking the gap and make sure the screws are removed. Now let's disassemble the housing in this way. Use your left hand, push the housing outward. Right hand, push inward to displace the housing, so it can be dismantled. Note: do not break it directly. It will danger the buckle of the housing. Okay, now the housing has been removed successfully. Here a proximity switch can be seen also. Then let's check if this proximity switch can work properly. Turn on the M1 machine. You can see a red LED here on the power on. Slightly weaker brightness. Wait for the machine to start normally. Use M1 Studio to connect the machine after machine is started. After connection is successful, turn on the truth energy of the motor so that we can move the robotic arm normally. Okay, let's first make sure that the proximity switch of small arm can work normally. We move the end gently. There is a black sensing film in this position on the end. When this sensing piece approaches to small arm proximity switch, its lamp will turn off from light. Let's try again. It is now bright. Slowly moving past, it will turn to off normally. Turn back a little and it will light up again, so that we can confirm that this proximity switch is okay. In the same way, now we confirm the proximity switch on the big arm. We move the big arm past slowly. It is now bright. Then extinguish. Turn back a little bit. It's on again. So we can confirm that this switch is okay. Before we confirm the proximity switch of the axis, we should turn off the teeth. First, turn off the machine. Note that we must turn off the machine to operate when we disassemble the housing or connect wire. The same as other, the axis with 5 M2.5 screws on this side and 5 on the other side. After the screw has been removed, there is a buckle on the below. Gently break it with your left hand fingernails. Open the buckle. After opening, we'll verify that the screws are removed completely. Note that this housing cannot be removed with force. Slowly open the button with your fingernails. Finally, separate it. Now, we start the next time. Okay, now let's take the Z-axis housing apart. This is Z-axis proximity switch. Connect to M1 now. Same open tools energy. Now, slowly move the Z-axis up. Close to this proximity switch. The current state. This is bright. When moved up, it can normally go off. Then we will go slow down. When it comes down, it will shine. This indicates that the proximity switch function is available. Okay, let's turn that tools off again. In this way, we can adjust whether the Z-axis, large arm, and small arm proximity switch is okay. There is a problem. How do we replace the proximity switch? Now I will show you. First, shut down. After it, we can use dagger pliers or sharp mouse pliers or other tools to loosen this place gently so that this place can move normally. Pull it down after it can move. Remember the jack position. Okay, now this proximity switch has been removed. We need to replace it with a new proximity switch. Only one screw is needed here, and this spare screw can be removed below. Then one gasket and one screw, still locking this position. How much space is needed here? Here, we take a piece of A4 paper, twist twice, approximately 4 layers of A4 paper thickness. Pat in this position. Small paper may be used if A4 paper is considered to be larger. Turn it normally to this position. Then screw this down. Tighten this after tightening. Okay, let's reconfirm the present position. No interference with the housing at the end. Then we plug the wire back in. Restart. Now let's test if this proximity switch is working properly. If we can normally sense that we have successfully installed. If normal sensing is not possible, the installation is a fault. Okay, let's connect to M1 Studio. Open Tools Energy. This proximity switch is now on. Slowly rotating the end. That's this black sensing film sense our proximity switch. Okay, normal extension. Remove normal light. Okay, which means that our replacement is successful. Okay, let's go off the tools. We have installed the extra line close to switch back on this draw. Snap back into this slot. The same is true of the proximity switch of the same large arm that needs to be replaced. The thickness of the 4-layer A4 paper is used here is to isolate our sensing area from the switching area. Then it should be noted that the Z-axis proximity switch, Z-axis position, we normally look at the bottom, approximately 6 to 8 mm extension. Take 6.5 mm if we are normally. Tighten this up the same way. After tightening, we power on normally. If we changed the proximity switch, reset 0 required, because our zeros are calculated based on this proximity switch. First, we found the M1 Studio icon. Right-click the location of the files. Move up to the Tools folder and open. First open Find. Initialization, double-click. Connect after opening. Click the logo icon at the upper left corner for 5 times, and the interval is about 0.5 seconds. After this type message box appears, click OK. Then click Debug. Then we need to look at the parameters of this encoder. 167 to 168 are OK. Then let's click back to this. Turn on the motor tool's energy. Return the motor back to the lowest 0 position. If you do not know where to return to 0, please read the instruction. The gap of the housing needs to be aligned with the gap of another housing. Then turn off the motor teeth. The third access limit is property. We don't care about this because it is normal. Click Debug. Then point. Interpose. After the dot, we will find that X is 400, Y is 0, Z is 0, R is 0. If you need a fixed end at this time, you need to remove the end. Then we point, interpose, and then we point home directly. Perform 0 return operation, because the return to 0 at this time is the parameters that requires the first return to 0. Reference is made to these parameters for the subsequent zeroing. OK, perform 0 return. Wait approximately 1 or 2 minutes. The machine is now in the limited position. It senses the proximity switch. It stops when the proximity switch is centered. After it stops, it returns to the initial position of 010. In this case, it can be seen that X is 400, Y is 0, Z axis 234, and R axis 0 on the software. Then return to 0 is complete at this point. Now, our approach switch is based on the way we have just done. Thank you.